The next session is Infrastructure is Code with the AWS Cloud Development Kit by Kevin Hassan.
Okay. Hello, everyone. Welcome to the Infrastructure is Code with CDK. I want to thank Ordina for this opportunity. And the session is going to be in two parts. There's going to be a presentation and then at the end, a live demo. I would like to ask to hold the question later. And if we don't come to answering the questions, don't hesitate to reach out to Kevin van den Abelen, and he will give you my contact details. So let's get started. My name is Kevin. I'm a solutions architect at AWS, working for the public sector in the Benelux. Let's see. Yeah. So instead of a traditional about me slide, I will be talking a bit about my journey through the infrastructure as code. Yeah, how it happened. So back in the day, when I started as a Java developer, it's about 15 years ago, all I had to do was program. Those were the good old days. But at some point, curiosity got the better of me, and I had to be involved with infrastructure and with deployments, application deployments. Looking back at that time, before I opened Pandora's box, I can say I was very happy, and in the beginning it looked like the dark ages. So in the beginning we started with doing everything manually. That was of course easy to get started. However, it was not reproducible, so it was also error prone and also time consuming. So to do those manual deployments, you needed to have documentation. Those were on wikis or cookbooks or whatever, and they were almost never up to date. And I'm sure that a lot of you can relate to that. Sometimes we even had to go on a crusade to find the wise old man, or as on the slide, ask Bob, he knows, within the company, to give you that last missing piece of information for you to finish your work. When you were that far down the rabbit hole, all you could do was hope that this person was still working for the company and not on a holiday. So after doing everything manually, we decided to start automating stuff, and we decided to do that with scripting. Scripting everything in Bash or PowerShell or whatever scripting language that was needed. This worked until the complexity became too much and it became too hard to maintain. And that complexity was because of all the extras that you had to build in, like waiting for resources to spin up, updating resources instead of creating components and so on. The best advice when someone came to me about those scripts in those days was, if it works, don't touch it. So at some point, we evolved then to a declarative approach. This was an important step towards infrastructure as code. In my opinion, it was, for me at least, it was a bit like the true, between quotes, introduction of infrastructure as code. It would allow us to use provision engines such as AWS CloudFormation, Terraform, and others. And these tools, they would hide the complexity of state management, of rollbacks, drift detection, error management, and so on. So what would you do here is that the developer would describe, or the sysadmin or whatever, would describe the infrastructure in a declarative way and hand over that description to the provision engine to be executed. This declarative way, it was done in JSON or YAML format, and due to its verbose way of declaring everything, it also became very hard to maintain at some point. And when talking about missing features for a declarative approach, a lot of people start mentioning that they miss a programming language. So up comes the next idea, which was to use generators, like Troposphere, like GoFormation, like SparkFormation, and many others. With those generators, we would write code that would generate the JSON or YAML templates based on the classes and the methods that you would write in the programming language. It would offer you the ease of use then to have if statements, to have loops, and so on. So now, from a development standpoint, we're getting somewhere. We could start programming this infrastructure, but it would still mean sometimes learning new skills, new languages. For example, as a Java developer, you would have to learn Python to work with Troposphere. So on top of that, and then we are at in the current times, let's say, we have the emergence of new tools such as the AWS Cloud Development Kit or Pulumi. These provide you with tools and frameworks to create your own custom abstractions for building your cloud infrastructure. So what is the AWS Cloud Development Kit? CDK, it's an open source software development framework that will allow you to model and provision your cloud infrastructure using, and that's the big power, using familiar programming languages, like as you can see on the right, Python, JavaScript, TypeScript, Java, and C#. This also immediately shows you the big power. Like I said, you don't have to learn a new language if you know one of those 5. You don't have to do a context switch to other programming paradigms, and you can start using your favorite IDE with all the tool support that you're used to, like syntax highlighting, auto-completion, inline documentation, and so on. The CDK is also, it offers you an abstraction that is managed by AWS and the community. And let's not forget, the most important part here is with this CDK, you will also be able to build your own abstractions and components of infrastructure and applications for you to use and reuse in other projects within the organization. There are 3 main components of the CDK. There is the core framework, the CLI, and the constructs library. With the core framework, you can create and structure your applications that contain one or multiple stacks, and a stack is a logical unit of infrastructure, and stacks each of them can contain multiple resources. Once again, those CDK stacks, they are mapped one-to-one to CloudFormation stacks. And it's a nice tidbit for the ones that know already CloudFormation. Talking about the application and the stacks and so on, it's a good divide your resources into stacks with different life cycles. For example, this means that you would create one stack for your network infrastructure, such as your VPC, virtual private cloud. Another stack would have your container cluster in it, for example, and yet a third one would have the application in it that will be running in the cluster. With the CLI, the command line interface, that will help you to interact with the core framework, and it will help you to initialize the project structure, to inspect differences between deployments, and to do deployments to AWS easily. The constructs library, that's a set of components that are crafted by AWS to create resources for you, for specific services for you to use. And this will help you to limit needed libraries in your project and use only the dependencies that you need. It's also built with best practices and security considerations in mind, and all of this to provide you as a developer a good developer experience and ease of use and a fast iteration cycle. So let's have a look at an example. This is an example written in TypeScript, and on the first line there, const VPC and so on, you can see what we do is we create a new VPC with 2 availability zones. And then we're going to create a cluster, which we're going to add to this VPC. And then the third part is we're going to create a Fargate service with an application load balancer in front of the application that you want to deploy to this container service. All of this in a couple of lines, and this will generate 830 lines of CloudFormation template. So this means CDK will for you generate 830 lines of CloudFormation template with separate VPCs, internet gateways, routing tables, application load balancers, clusters, and so on. So how would we use this in a development project? So let's have a look at a typical development workflow. Like I said, CDK will help you with initializing your project. So you do on the command line interface, you do a CDK init, and this will generate a new project structure for the specific programming language that you use. And you can start creating your application. You can add your stacks, you can add your constructs, your resources, and so on. And once you're done with that, we have to build a project. So in this case, we're building a TypeScript project we use the command npm run build. Then, of course, you would like to see how this code will look like in CloudFormation. So you can run the CDK synth. And this will generate CloudFormation templates and assets for you in a bundle that we call the Cloud Assembly. Before we deploy, you always want to see what changes will happen if you deploy this Cloud Assembly. What resources will be deleted, created, updated, and so on. So you can do that with the CDK diff. And then with CDK deploy, you push those changes to the cloud, and the AWS CloudFormation service will pick that up and will start provisioning the resources for you in your AWS account. And you have your application and your infrastructure up and running in AWS. So that's a typical workflow. Let's have a chat now about constructs. So, as mentioned before, there is the AWS CDK includes the AWS Construct Library, and this contains constructs for all services. For example, the S3.bucket class in the CDK represents an Amazon S3 bucket in your account. DynamoDB table class represents a DynamoDB table, and so on. While this library is your starting point to create resources, one of the big advantages of CDK is that you can make a composition of services and create complex infrastructures, such as a network setup, clusters, databases, and so on. And let's not forget, you can start creating your own custom resources as well. So let's have a look at, well, I mentioned constructs a couple of times already, so let's have a look at the various levels of constructs. They are organized in 3 levels. Level 1 are the constructs that are generated from the CloudFormation resource specification. So this is a one-to-one mapping between a CDK class and an AWS resource in your account, or an AWS resource specification in the CloudFormation. Level 2, those are the higher level service constructs to represent resources such as Amazon S3 buckets or a VPC that include other resources. So this can be a composition of multiple resources, but it's still tied to one service. And I'll give examples on that later. Level 3. Level 3 constructs are opinionated abstractions. Sometimes we also call them patterns that are created by AWS. For example, as in the example that you saw earlier, the ECS service with an application load balancer and a VPC. Or it can also be third-party components from the community, or your own components built in your own libraries. So typically this is the level where you would create your own abstractions that you can then reuse internally, or if you publish them, can be reused by anyone. Okay, so yeah. So lower level constructs, level 1 constructs, they have direct access to the, they are directly linked to the generated CloudFormation elements. So what you can see on this slide, the top line of code is going to create an S3 bucket with the name my-bucket. If you do a CDK synth on that, it will generate the second snippet that you see below that. It will generate, and there you can see it in the YAML format, it will generate 5 lines of CloudFormation template to create your resource being an S3 bucket with the name my-bucket. And we have this for all AWS service components like an EC2 instance, a KMS key, and so on. Level 2, that can generate a more complex structure. They can contain multiple resources, but they are still scoped to one specific service, in this case, a VPC. With this single line of code, we're going to create a ready-to-use VPC that spans 2 availability zones. It will have 4 subnets, and it will have 65,536 IPs split equally over those 4 subnets. It will create an internet gateway, route tables, and everything else that you need to have a fully configured VPC. So anyone here in the session that has built a VPC from scratch in CloudFormation, I think you can relate how challenging that can be and how long it would take in CloudFormation. Here we have a ready-to-use VPC with just one line of code. And you can change any option in it that you want and adjust it to your requirements. So if you would say, let's have 6 subnets, it's just one parameter that you have to add to that line and it's okay. Then level 3. The snippet of code that you can see here was in the first example as well, but it was the third part of the things that I explained. So this snippet of code is going to generate the 2 parts with an orange border around it below. So it's going to create an application load balancer with the corresponding security groups, with a task definition, listener, and so on. Then it's going to create a Fargate service with the EAM roles, identity access management roles, and policies with log groups, CloudWatch, for monitoring, and task definitions. And it's going to deploy an application into that. And all of that by just providing 2 parameters, the cluster, and then the name of the Docker image that needs to be run in that cluster. This shows you how powerful level 3 constructs can be. You can also create your own abstractions, like I mentioned before, that you can reuse in other projects or that you can publish for others to use in the open source community. And I'm waiting on the screen. Yeah, okay. There is also the AWS solutions constructs, and these are vetted architecture patterns that are available as open source extensions of the CDK, and that they can easily be assembled declaratively in your code to create a production-ready workload. It's a growing library of best practice architectures with security as a top priority, and you can filter the entire library to find the right solution for your use case. CDK, it's an open ecosystem. There's a public roadmap to show you what features are being prioritized by based on the customer feedback. And we are very happy to have many contributions from the community, you guys as well. And we would love to have your voice in future development of the tool. There are also many other resources that you can use. You just have to have a look around on GitHub, for example, to find some of them. If you want to try it out, here are a couple of links. I'll show them again later. You want to contribute a couple of ways. And the link that I provided there below at the resources is the link to the vetted architecture patterns. So let's have a demo now. And I'm going to try to do it in 15 minutes with the explanation included. So we're going to build an application, serverless application, where you will have your backend running on AWS Lambda, which will write some data to an Amazon DynamoDB, which is our NoSQL key value database. And it's being fronted by an API gateway for a REST API. So it's not an official architecture diagram here, but it just shows you those are the 3 services that we will be using in the demo. Okay, so I've done already a CDK init. So what you see here is the Java project with its typical structure. It's a Maven project, so you see the POM file, and let me see on my screen here. Okay, it's still readable. Okay, so it's a POM file, and in this POM file, we're going to define the dependencies that we need to start using CDK. So we have the core, we need the core to start working. Someone is requesting control, we're not going to do that. So we need the core to have CDK working, and then we have for each of the services that I mentioned, Lambda, API Gateway, and DynamoDB, we have a dependency that we have to start using. A fourth component here is an open source third-party component that is built for demo purposes to show you content of a DynamoDB table. And then we have the typical dependencies for unit testing. Okay, then we have our main class. What I do here is I'm going to create a new stack, give it an ID, and this ID we will find back in the console later. And I'm also going to give it a default environment to work in, which I have defined here. So basically, I'm telling it in which AWS account is going to work and on what region I want it to be deployed. There are several ways on how you can do this. If you don't mention anything, the CDK will look at your active profile in the AWS CLI, and it will take that as its default target to deploy. So I don't have to change anything here. So now let's start. Ooh, there's too much code here. Let's remove this. So let's start building our application. So as I said, I'm going to have a backend which is writing to a DynamoDB. So let's create our DynamoDB table. So I'm creating a table with a partition key named path, and it's a string. I'm giving it a table name to easily find it in the console. I'm enabling encryption with AWS KMS, our key management system. I'm setting a removal policy so that when I destroy this application later on, it's also destroying the database, and I'm going to build this. Next thing that we need is we need to tell CDK that we will need a Lambda function. So let's create that one. So I'm creating a function. It's called hello handler. The runtime is Node.js. So it means I'm going to write a JavaScript Lambda. The code is going to be included in this code base for the sake of the demo. There are different ways on how you can tell it where to find the code. I'm telling it what handler to execute when it's being triggered. And again, I'm giving it a function name to easily find it again in the console. And I'm building this. And of course, we need the Lambda itself. And as I said, it's JavaScript. So I'm creating some JavaScript code where I'm importing the DynamoDB SDK client so that we can write to a DynamoDB table. So what do we do here? We're going to create a promise that will find the table name from the environment variables. It knows what key to use. It knows what update expression it has to do. So basically what we're going to do is we're going to create a REST API where we're going to store in DynamoDB, we're going to store the path that was called and the number of times that path was called. And once that data has been written to DynamoDB, we're going to return a status 200 with a message saying, hello, join 2020, you've hit, and then the path that you entered. So we have the database, we have the backend, now we need the API. So for that, we're going to create our API gateway. What do we do in this API gateway? We give it a name, again, to easily find it in the console, and we're going to tell it where the handler should be, and the handler is the function that we created above it. And then we're going to create this. So now if I do a CDK deploy, and I'm going to do a deploy immediately, I'll do a diff later to show you. Let's deploy this so that you can see it being deployed. And then we continue with the explanation. Okay, so yes, okay, start deploying. So now you wonder what is showing here. So basically what we execute CDK deploy, and then what it tells us that there can be potential sensitive changes to your infrastructure, and it gives you an overview of those changes that are happening in our identity access management. So it's saying that there are some statement changes, there's some policy changes, and so on. And now it's deploying. Let's have a look at the console. So as I said, when you do a CDK deploy, you're going to give your Cloud Assembly to the CloudFormation service in your account, and that one will start executing it. So let's have a look at CloudFormation. So here you can see that we have Ordina join 2020 with a create in progress, so it's being created. When you click on that, you can see all the events here that are happening, that are being triggered or told by CDK to CloudFormation. So, and you can also see all the resources that are being created for this stack. Let's have a look here again. Okay, so you see here all the resources deployed. And the output that it gives here is the URL on which you can find your REST API now. You can still put root 53 in front of that, for example, to have a different URL, or you can use your own DNS and so on. Before I'm going to show some more in the console, I'm going to add some more code here because that takes some time before it's deployed. And now, with what we have deployed now, you would think, okay, we're done. We have a REST API that we can call, and then a Lambda will read out some of those things and write it to the database. Yes, but no. So yes, we have that. No, the Lambda cannot write to the database because, and I will show you, because it will give you now an internal server error. And why is that? That's because of security considerations. DynamoDB doesn't allow anyone to write to DynamoDB unless it's explicitly mentioned that a person or a service is allowed to do that. So what do we need to add for that? We need to add some permissions. So we're telling it, we're telling the table that it needs to grant read and write data access to the function. So with this line, we allow the Lambda to write or read to or from the DynamoDB table. And for our JavaScript to work, as I mentioned before, it needs to know the table name. We're also adding an environment variable to the function, so it knows what the table name in DynamoDB actually is. Otherwise, it doesn't know where to write to. And then I'm going to include that as well immediately. We're going to create third-party constructs in order to look at the DynamoDB table data in a browser. So we're giving that a name, we're telling it what table to use, how it needs to be sorted, and so on. So I'm going to do a CDK. No, hang on. Let's do it like this. Otherwise, it's too much to see. So now if I do a CDK diff, it will tell you what the difference is between what I've written here and what is running in my account. So what it's going to tell you, it's telling you that there are some statement changes. You are going to allow helper, allow all DB. And then a bit further, it's also going to say, well, you're going to add an environment variable to the Lambda for the Lambda to use. Okay, so let's add this line again, join viewer. Okay, CDK deploy. So this is showing a lot more. Why? Because this table viewer component, it's actually also generating security changes to read data from DynamoDB. It's also creating a Lambda and so on. Okay, so we're deploying this. And it's going to take a bit. So as I mentioned, with the previous code, we were going to create a Lambda, a DynamoDB table, and an API gateway. So let's have a look at DynamoDB. Let's start with the database. Okay, and I'm waiting on the screen. Okay, so as you can see here, in the code we wrote, create a Lambda, create a DynamoDB, give it the name Ordina join 2020 table with a partition key paths and with encryption with KMS. So that's all here. If you click through, you can see a whole lot of information and things that you can change, but you can also see the items in the database. At the moment, there are none. Why? Because it wasn't working yet to write to the database. Let's see how far we are here. Okay, not on yet. So this is with the 3 or 4 lines of code in CDK, we created this DynamoDB table. So let's have a look at the Lambda. And you can see now we have 2 functions. This is the one that we created. So it's the Ordina join Lambda 2020 Lambda. This one, that's the one of the table viewer component that is being deployed as we speak. So if we look at the one that we wrote, you can see the name that we mentioned and that it's being fronted by API gateway. And here you can see the code that we wrote to run in this Lambda. And a bit further here is the environment variable that we've also put. So that this line here, it knows the DynamoDB table name that it has to use for the query that it needs to do. API gateway. As you can see, there are 2 APIs here. This is the one that we created. This one, the viewer endpoint, is the one generated by the table viewer component that I'm using for the demo. So if you click on this one, you'll see again a whole lot of details on API gateway, what you can do and so on. So let's have a look at our deployment. Okay, and it's done. So now you can see 2 outputs. So basically we have the one for our API and the other one is for the table viewer. So let's have a look at the API. So let's put some data in the database. Okay, and here now we have a result. It says hello join 2020. That's not really readable. Okay, like that. Hello join 2020. You've hit slash. If you're going to put behind that Ordina, let's put it again, or something else, like join 2020. That information is going to put in the database. And to show you, I will show you here. Let's go back to our DynamoDB. Tables. Table. And then the items. So you see here the 3 items that we've executed now, and that we've gone to. Of course, you don't want to give people access into your AWS console to see some data in DynamoDB. So you would have to have a front end to show you that data. And that we have done with this table viewer component, as I mentioned. And I'm waiting on the screen again. And that is this URL. So with that, with this piece of code, we've put up again an API gateway, a REST API, a Lambda, and given it access to our DynamoDB table so that we can show the information a bit nicer. So here you can see the information. Let's add one more. And you can see the data being updated here. So this is all very nice. Huh? So with CDK, we've set up the infrastructure that we need. We've even deployed the application. If you don't want to deploy it from CDK, you can have your different pipelines to deploy the actual applications. And this is good. Let's say this is the infrastructure that we want. We don't want anything changed to that. So because it's your favorite programming language, and you know you can do unit testing and everything in there, so let's add to this project a unit test. So test. So what I'm doing here is it's a simple test that I'm going to do. The test I'm going to do is I'm going to look at the CloudFormation template that will be generated by the code that I have in my IDE. And then I will look at the CloudFormation template that I'm expecting. So basically what I did earlier was I generated the CloudFormation template from what was running in production, and I've put that here as a test resource to be used in my test. And then I'm going to assert that the expected value is same as the value. If you run that, do that with package, or I can just here as a specific test case. It's all good. It's all the same. If you're working on it and something happened and someone removed something or added something that you don't want, like for example, let's remove the encryption, so the data wouldn't be encrypted anymore. And you're going to run your test now. And it's going to tell you that the message that I'm putting down there, it's telling you infrastructure changes will be made. If you execute this now, changes will be made. So let's not do that because we have what we want. So in those 15 minutes, I've shown you how you can start with CDK in Java. You can do it for any of the other 4 languages as well. How you can start creating a stack, create DynamoDB and so on, and also how to test the infrastructure that you have. So again, if you want to try it out, there is a CDK workshop. My demo is based on this website. It will help you almost the same by your. There is a sample link and even more on the third one. If you want to contribute, there is a Gitter that you can join. There is the AWS CDK on GitHub. There is a GSII that you can also join on GitHub. And if you want to have a look at the vetted architectures, you can go to the resource that I'm providing there. So with 30 seconds left, I want to take this moment to thank you. I hope you enjoyed it and that you learned something from it.